Hey guys, and welcome back to another video. Welcome to the part 2 of my Entity Component System tutorial series. Today we are going from concept to working system. So you may have watched part 1 about the Entity Component System and its theory. But now what? Now we should build. So this is a hands-on tutorial. We will write real code that runs on a Hytale server. And you can code along. So the complete source code is in the video description. And you can pause anytime and type along, or you can grab the finished code and experiment with it. So we're going to build some kind of experience and level system as our example project. And we will continue this project throughout this series. So we have to look at some very different things, like for example the data model. We need to look at what to store versus what we need to compute. We will look at the player setup. So for example, listen to join events and do some kind of initialization on there. We will look at how we can earn experience points by killing monsters, and we will take a deep dive into event-driven notifications inside our mod structure. And of course, we need some kind of debug commands to make our life a little bit easier. So we will look at this kind of role-playing game system, RPG system, but it's just a vehicle. The patterns you learn apply to any feature you want to build. So this is part of an ongoing series, and in future parts we will expand this foundation. For example, we look at things like health regeneration, like ticking systems and delta times. We may look at combat stats and quests and achievements, for example. So what I want to say is that your ideas matter. So what features would you like to see? What concepts do you maybe find confusing inside Hytale? So please leave a comment, and your feedback will shape the future of this tutorial series. So why do we program a RPG system in this case? Because it naturally uses all the core patterns we need to use. It uses components for data, it uses systems for life cycles, it uses events for communication, and commands for testing. And so the patterns transfer to other features? Yes, exactly. So building systems, stamina bars, inventory logic, all that, they all follow the same principles. So basically learn once, but apply everywhere. So let me show you the quick architecture overview of this upcoming system we want to build. So we will have some kind of different XP sources. So there are many ways you could earn experience points to level up in our potential system. So for example, a monster kill, or our command, or maybe in future videos, a quest reward. So we need some kind of way to bundle all those sources into one single source of truth for XP handling. We need some kind of central processing, one handler that does the work. And then we also need to have some kind of event system for our level ups, so multiple systems can react, for example. So we may want to send the player a message, or we may want to have an achievement system, or we want some kind of bonus system depending on which level you have risen to. So this is a quick architecture overview, what we are going to build and how Hytale patterns are gonna come into clutch for that. So please make sure that you have Java 25 installed as a project SDK. You need Gradle, or at least I use Gradle. You can use Maven, or you can use nothing at all, but I think it's just a little bit more convenient. You need the Hytale server jar placed, at least in this case, inside a folder called libs inside our project. And this will be my package root, but you can change the package name to anything you want to do. So this is like the basic setup you need when you, for example, open a new Java project inside IntelliJ. So this is my build Gradle KTS file. So basically telling Gradle, hey, I have some dependencies and they are compile only. So we want to access like the class names, but we don't want to bundle it with our jar file. I have defined a jar task, which defines a duplicates strategy, which will be important for later videos. And just for my convenience, I have a custom task called deploy to server, which just takes the jar file and copies it into my mods folder. So you may want to get it too, or you just copy it by hand. So we also need our manifest.json file, which basically defines our plugin structure. So we give it a group, a name, a version, and our main class path. And the main must match your plugin class. If it is wrong, the server will not load your mod. So if you use IntelliJ, just select Java 25. If you don't have it, download it. Just Google OpenJDK 25. Be sure to define your sources and resources. It should happen automatically if you set up a Gradle project inside IntelliJ, but better be safe than sorry. And to look out, this will be our final project structure. So we will have a components folder, or package, which contains our ECS data containers. We will have a level package for lookup tables, game rules, more on that later. We'll have an event package, systems package, handlers package for event handlers, commands for commands, and of course our main RPG systems tutorial.java class at the start is our main entry point. So before we start, the complete source code is linked in the video description. You can code along or grab the finished project. It's absolutely your choice. Be sure to check out the website. Be sure to join the Discord. And if you want, follow me on Twitter. And if you have any questions or any ideas, drop them in the comments. I will try to read everything. So let's start with part 1, the data model. What to store and what to compute. So, okay, for an XP level system, what data do I need to store? So let's think about what we need to display first. So we would want to display the current level. We would want to display the total experience points a player has and the progress to the next level and the experience points needed for the next level. So I store all of that in a component, and that's the intuitive approach. You could do that, and let's explore that and then maybe see if there's a better way. So the intuitive approach would be, okay, we have a player RPG component, and we have those 5 different attributes: total experience, level for the current level XP, XP to next level, and progress. And this works. It can work. Many games ship with exactly this design. It's simple, it's direct, and easy to understand. But there's a trade-off. So what's the problem with storing all those fields? Well, first of all, it's redundancy. So if total experience is 150, then level 2 is a fact and not a choice. That means storing both means they can get out of sync. But you might say, hey, I'm always careful enough to update both. And that's kind of the trap, because being careful doesn't scale, and we want to scale in game development. Because if you have one forgotten update path, one edge case, and then you have players with, for example, 500 experience points at level 1. So there are different pros and cons with this approach. We have, like, with storing all fields, we have fast reads and no computation, but we must keep 5 fields in sync. When we only store experience points, for example, we could have a single source of truth and compute everything on every read, which would be the con of that. So for this tutorial, we are going only to store one property for the player, which is called total experience. And now let's build that. So we need 2 files. We need a file inside the package level called XP table, which will be our lookup table, or in other words, our game rules, which says, hey, at which experience points do you rise to which level? And then we will create our player RPG component, which contains only the player data. So let's create the XP table. So inside your IDE, create a new class XP table and add a long array of level thresholds. And those are our levels. So level 1 starts with 0 XP, 0 experience points. But level 2 is achieved with 100 experience points. So it's basically just our XP curve as data. And the index equals level -1. So that's how we would access that. So from this variable, we can derive the max level, which is just the length of the array, and we define the start level. So we derive it from the array length. If we want to change thresholds, it just auto-adjusts, so we don't have to take care of that. We then initialize a private constructor, because we use this as an utility class, so we don't have any instances, we only have static methods. And then we want to create a method called getLevel4XP. So this basically finds the highest level whose XP threshold the player has reached, and we iterate from max level down. So create this method and then add the logic for this kind of method. So we do some defensive programming checks. So hey, if the total experience points is somehow below 0, just return start level. And then we just look at the max level. So hey, for example, if total XP equals 150, hey, has the player achieved level 10? No. Okay. Has he achieved level 9? No. Level 8? No. Level 7? No, and so on. And then we get to level 2, which the threshold is 100. And then it says, okay, yes, yeah, he has achieved level 2. And then we either return the level or we just return the start level. So next we need a helper method getXP for level, which is basically just the same in the opposite direction with some bounding checks so we prevent array index errors. Then we need a method called getXP in current level. So we want to get like the experience points in the current level we need and the XP to the next level. So those are basically just helper methods for us to get the derived data from our total experience points and the level curve. And if we arrive to max level, no more XP is needed, so we return just 0. That's like our choice of software design right there. So then we need another method called get progress to next level. So this is just like the XP in level and the XP needed. We just calculate it and return that, and that's that. So make sure to copy this inside your project, and that's all we need for the XP table class. So those are our game rules, and you can stop the video or you can look at GitHub. So you should have all those methods and this property, and we basically now have a stateless utility with pure functions. Now let's build the component. So we start with a simple class inside our components package, and we call it player RPG component, and we define an attribute that we want to save. In this case, only total experience. It's the only stored field. Everything else is computed. I start with just an empty constructor. More on that later. I will define a getter for that total experience field, and I will define a method getLevel. And in this getLevel method, I just call XP table getLevel for XP and pass in the total experience. So we don't have any level field. It's computed via the XP table lookup. So next I want to add getCurrentLevelXP, which is basically just a wrapper for our XP table methods. The next for getXP to next level and for getProgress. We can also define a method called isMaxLevel, so which says, okay, we get our current level, and you can see we use the getters that compute from total experience, and we compare it to the max level static constant defined in the XP table class. And then just another method for add experience, which is our main game logic to add experience to the component. So if we do a sanity check here, if the amount is less or equals 0, then we just return false, and then we get the old level, add the experience, and then get the new level, and return if the player has leveled up. So this method not only adds experience, it also checks if the player has got a level up from that experience gain. And that is everything we need to do for our player RPG component. But we want to save this total experience to the player, so we need a so-called codec. What's a codec, and why do I need one? Well, when a player logs out, Hytale saves their components to disk. And when they log back in, it loads them. And the codec tells Hytale how to convert your components to and from bytes. So it's basically like serialization. And yeah, exactly. Without a codec, your component data vanishes when the player disconnects. And with a codec, it persists forever. So let's add this component and codec data, because now our player RPG component is just like a normal Java class, but we need to add the Hytale specifics to it. So we need to add, first of all, here are all the imports that we are going to need, so like the entity component system imports and for the codec. And now we need our player RPG component class to implement the component interface with a generic, which passes in the entity store class. So Hytale now treats this as ECS data. And now we need some kind of static scaffolding. You may have seen in the first part of the ECS tutorial, we need to define a type, which is static, and we will initialize it later in our Java plugin setup method. So we set everything once at plugin startup, so we can reference it later. And now we need to add our builder codec, which basically says, hey, I want to define a new codec for this specific class. Now we need this expression with the double colons and new, which takes our empty constructor and says, hey, this is how you create a new class of this, like a new instance of this class. And then we append one keyed codec. And in there, it defines through the append method, hey, for this codec, we have those fields, and this is how you access them. So total experience in the string is the key in the save file. So you can actually go to universe players, and inside your players JSON file, you will see the total experience then. And we will say, okay, how you want to encode it. So it's a long data type. And with those lambda functions, we say, hey, how do we set the data and how do we retrieve the data? So everything we have covered in part 1. Now I want to define a new constructor, which takes in total experience, because this is going to be used by the clone method we need to implement below, because Hytale uses immutable objects and needs to create clones of objects. We need to override the clone method, and in order to do that, we define a new constructor. I will also add a method called setTotalExperience, which we may use for later. So this is useful for admin commands if you want to set the experience points. And we need to use nullable declarations. It's like an annotation for the clone. It was nullable before, but I think now it's nullable declaration. I don't know what changed. So we want to override this clone method and just say, hey, this is how you create a new instance of this class. And this is required. It creates a safe copy for the entity component system. And I want to override toString because it makes it a little bit easier for debugging. So it shows level, XP, and progress, and so on. So this is our final player RPG component. But now we need to register all this. And we will register that in our setup method. So every Hytale plugin has a main class extending Java plugin. And that's where components, systems, and commands get registered. And setup is called when the server boots, before any worlds load. And by the time players can join, all your components are registered already. So inside our main class, which in this case is called RPG Systems Tutorial, I have my class, which extends Java plugin. And this defines the entry point for Hytale mods. I will take the constructor and call the super constructor just to initialize it. And then I will override the setup method. And inside the setup method, which is called at server boot before the world loads and before players join, I get the get entity store registry. And inside this registry, I can define or I can register my component. I pass in my class. I pass in a key, which is like the ID, which is saved to the disk. And you should never change it, because when you change it, all the data is like not referenced anymore. So like this is the persistent ID for the codec. And then I pass in the codec, which is like a static property inside my class. And when I have this type, I register it through the setComponent type, so I can reference it in other aspects of my code, which you will see later. So like this is the Hytale pattern for components and getting access to the reference for that component. So yeah, if you change the string, it will orphan all existing data. And this is the wiring back to the component class. Now get component type, which we had also defined, works everywhere. And this is now for later. This Java main plugin, we would also register all our systems and all our events and all our commands, but more on that later on, just for transparency's sake, that this is also the place where you would need to define them. So, but for now, we only need our component. So please make sure that you also have your manifest JSON file, which shows the right main path with the group, name, version, and main. So very, very important, because if that's wrong, your plugin won't load. And make sure that you don't have any typos inside your main, because that happened to me once and I was wondering why my plugin doesn't load. So this is what we have built so far. We have our XP table class inside the level package, which has game rules and stateless utilities. And we have the player RPG component, which has player data, computed getters, and codecs. And we have our main plugin file, our main file, which registers all the components at startup. And we have our manifest. So please make sure to compile your project and test it out and load it inside your Hytale server to see if everything works as intended. So, what are the key takeaways for this part? We have a single source of truth for our RPG data. We only store total experience. And we define computed getters to get data like levels, progress, and everything just derived from the total experience and our level curve as an array. We have lookup tables for game rules, so it's easy to rebalance without migrations. Our codecs only save the raw data, so computed fields don't need persistence. And we have defined our component type holder, which is a static reference for ECS operations. So when you're in doubt, just store less. You can always add fields later. Removing redundant ones is very painful. So let's go to the second part, to the player setup. So we have the component, but when does a player actually get it? So we need to detect when a player joins and attach the component to their identity, to their entity. In ECS terms, we need a system that reacts to entity lifecycle events. So as you might know, there are different system types, and for entity added and removed events, we use the so-called RefSystem. It's specifically designed for lifecycle reactions. So we have RefSystem, for example, when an entity is added or removed. We have RefChange system when a component is added, changed, or removed. So very different ways to look at it, an entity or a component. We have a entity ticking system, which goes for every tick for matching entities, and we have a holder system, which is like a one-time setup thing. And there are many, many more systems, but for our case, we just need the RefSystem, which is perfect here. So the RefSystem, it works like this. It defines a query because we want to say, hey, which entities do we care about? Do we care about players? Do we care about NPCs? Do we care about players with a specific component, for example? Then we have methods like onEntityAdded, which is called when a matching entity enters the store, and onEntityRemove, which is called when a matching entity leaves the store. And as I said, the query acts as a filter. Only, for example, entities with playerRef component triggers all callback. So let's define a new class inside system called playerJoinSystem. And this class playerJoinSystem wants to extend the RefSystem, and as a generic, it gets past the entity store. So now this RefSystem reacts to entity lifecycles. We can override the onEntityAdded method, and it gives us many different parameters. For example, the ref, so the entity, then the add reason, so why it was added. We get the store and we get the command buffer. So now we can check, hey, if the add reason doesn't equals load, we want to return, which basically says, okay, we want to stop right here. So we only run on load, for example, player joins. Then I can get the player ref from the component. So I call store.getComponent, pass in the ref, and want to say, hey, I want to get the player ref component. And if the player ref is null, I want to return it. Then I want to get the player RPG component, which we have just defined. So I want to get it from the store from this ref. So I want to check if a player already has RPG data. If it's null, it's his first time joining. So I can add some checks. If the RPG data isn't null, so the player has RPG data, I want just to send a message back, hey, welcome back, this is your level. And I use the .formatted method on a string directly to pass in the parameters. So I don't need string concatenation. So it's a returning player. We show them their safe progress. But if RPG is null, I want to add a component to this ref. So I pass in to add component the ref, so the entity reference on which I want to add the component. I add the type of component I want to add, and then the specific instance of new player RPG component, so the initialization. And in this case, I create a new instance of this class, and total experience gets set to 0 because this is our starting point. And then I send a message like a welcome message. Hey, welcome. Your adventure begins at level 1. And we need to make sure that we use command buffer to add the component. More on that later. We also need to override the onEntityRemove method, but in this case, we just want to leave it empty. We have nothing to clean up. The component persists automatically. And as I said, the query, we want to define that we only want to look at entities with the playerRef component type. So it filters out NPCs, it filters out items, it filters out projectiles. I only want entities that have the playerRef component. So this is our player join system. But why do we need command buffer? So why do we need command buffer.add component instead of store.add component? Basically safety. So when onEntityEdit runs, Hytale is iterating through entities, and modifying the store directly could corrupt the iteration. So the command buffer queues it for later, and yes, that's exactly all it does. All commands are applied after the current iteration completes. It's like a to-do list that Hytale processes when it's safe. So please make sure that you can read from the store inside the system, but if you want to make changes to the store or add components, please make sure to use the command buffer. And after that, please make sure inside our setup method to register the system to our registry with the register system method. So that's all it takes. And now the systems are registered once at startup. And Hytale calls getQuery to know which entities to track. So a player connects, Hytale loads the player entity from disk, the entity enters the entity store with a add reason. Our player join system.entityEdit is getting triggered. We will check, hey, has the entity or the player that has joined a player RPG component? If so, send them the welcome back message. If not, create a new component via the command buffer, and the command buffer applies that after the iteration, and now the player has RPG data. So, what we have built? We have now our system package, and inside there we have our player join system. And the RefSystem for lifecycle events, the query filters to player only, we have add reason load for join detection, and the command buffer for safe modifications. So if you want to react to the entity lifecycle, use the RefSystem. If you only want matching entities, use the query as a filter. You can distinguish between loads and spawns and transfers, for example, and we need to use the command buffer for writes. And very, very important, the component persists automatically. The codecs handle save and load. So initialize once and persist forever. The player RPG's component survives disconnects, server restarts, and world transfers, but we may want to add like an autosave system because we want to handle things like server crashing, for example, but more on that in more future parts. Now let's take a look at the XP architecture from event-driven design for flexible systems. So now I can store experience points, but how do players actually earn it? So there could be many ways. For example, kill a monster, complete a quest, use a command. The question is, how do we connect all these sources to the RPG component? And you might say, hey, just call component.addExperience directly. And that works, but it creates something called tight coupling, because every XP source needs to know about the component. It needs to handle level up checks. It needs to send messages. We could do better with events. So on the left side, you see the direct approach. For example, in monster kill system, we could call the component and call addExperience, and we need to check the level up. In quest system, we would also call addExperience and check for level up. And in a command, we would also need to call addExperience and check for level up. So we have tight coupling and duplicated logic. Whereas in events, we could just say, hey, I want to dispatch some kind of give XP event to the specific player ref and want to award him with, for example, 50 experience points or 100 or the amount I got from the command. So we want to bundle the responsibility into a single source. So XP sources, like a monster kill, like a quest, they just dispatch events and one handler owns the logic. So changes happen in one place. So why only one handler? What if I want multiple systems to react to XP? So we need to think about what giving XP means. We want to read the current XP, we want to add an amount, we want to check for a level up, maybe cap it at a max level. So that's logic that modifies state. So if two handlers both try to add XP, we're adding XP twice, or have a race condition, or conflicting level up checks. So when we're modifying something, you want one owner. Like GiveXP event says, hey, please add experience points. And one handler fulfills that request. Okay, so far so good. So one handler for XP. But what about level ups? The handler detects when you level up, right? Yes. So the GiveXP handler, which we will code in just a bit, calls add experience and checks if the level changed. But now what? Send a message, grant an achievement, apply stat bonuses. So should we put it all in the handler? And that makes GiveXP handler a monster class that knows about everything. And what if another plugin wants to react to level ups? They can't modify our handler. So the solution would be a second event. So when GiveXP handler detects a level up, it dispatches another event called level up event. And this is a notification. Hey everyone, this player just leveled up. And anyone can listen to that, and yes, our plugin adds a message handler, an achievement plugin adds theirs, a stats plugin adds theirs, so everyone reacts independently. The XP system doesn't need to know they exist. So we have two different needs. With the GiveXP event, we have like, hey, please do this thing. So we could have multiple callers, but only one handler. And the handler modifies state. So only one system should own this logic. Whereas the level up event is more of a event like, hey, this thing happened. We have one caller, but multiple listeners. And the listeners react. They don't modify state for this specific thing. They send a message. They grant an achievement. And any system can add a listener. The difference, it isn't technical. Both use the same event system. It's more about intent. Whereas we look at it as a request or a notification. So this would be the complete flow. For example, we have multiple sources, like a monster kill, like a quest reward, like our command, which dispatches the GiveXP event, which gets handled by the GiveXP handler. The GiveXP handler takes the player ref and the player RPG component and calls the add experience method. It checks, hey, has the player leveled up? If so, we want to dispatch a level up event. And this level up event can get handled by multiple handlers. For example, our level up handler, which we will implement, which sends the player a message, hey, you level up. Or we can use it for achievements or for like a future game logic, like boosting stats or something. So, okay, but how do we do that in Hytale mods? How do I actually create these events? So, Hytale has actually two event systems. For cross-system communication like ours, we use the iEvent interface with the global event bus. And that's very simple, but what's the other one for? So we have ECS events also, which is for entity-specific events that are part of the entity component system tick. Like for example, damage being applied. But our events are more like plugin messages that any system might care about. So we will take a look into ECS events in the following series, in the following parts. But for now, our choice would be the I event, which totally fits our needs, because experience points and level up are cross-cutting concerns that plugins or other parts of our mod might want to hook into. So let's create two event records, GiveXP event and level up event. And I will implement them as Java records, as immutable data carriers. You could also create them as Java classes, but Java records are just a little bit more elegant. So I define a public record, GiveXP event, and inside the constructor, I pass in the attributes I want this record to have. So in one, I want to have the player ref, which should be non-nullable. And I want the amount XP to give as a long. And I say, hey, this record implements the iEvent interface. So the Java record is a immutable data class. It auto-generates the constructor, getters, and equals. The player ref is who gets the experience points, and the amount is how much XP is going to get. He's going to get, And the iEvent implementation basically means with the void, hey, we don't have any return value. We sort of have a fire and forget pattern. And to make our lives a little bit easier, inside this record, I define a static dispatch method, which takes the player ref and the amount. This helps us so the callers don't need to know about the event bus and about the implementation. They just need to know about the event and which fields it has. And it can call a dispatch method. So inside, I get the event dispatcher from the event bus. So we take Hytale server.get event bus.dispatch for. I give it the reference to the class, and it handles all internally. So listener lookup internally, and I can check, hey, has this event a listener? And if it has a listener, I want to dispatch the event. So it avoids creating objects for nothing because we want to skip if no listener is registered. So that is everything we need to do to create a custom event that is like separate from an entity event inside Hytale. And now we can use this giveXP event and its dispatch method from anywhere in our code where we want to dispatch XP and where we want to give XP to a specific player. So the callers don't know or they don't care how XP is processed. They just dispatch the event. The same goes for the level up event. So please create inside the events package a new Java record called level up event. And we define the player ref. And we pass in the old level and the new level. So we want to say, hey, okay, who leveled up? And we want to get the transition. So what was your old level and your new level? And I define a little helper method called levels gained so we can get the difference. So convenience method for listeners so we don't need to compute it themselves. And we want to look at, hey, maybe a player has gained 3 level ups because he killed a monster, for example, like a boss, and it just gave a huge XP reward, or he just created completed a huge quest, and maybe we want to create different effects based on how many levels he has gained for this level up. And also in this level up event record, I want to add a static dispatch method. So we have these 3 parameters, who, from, and to, and the full context for any listener. So that is our level up event. And yeah, as I said, why it has listener check, we just want to do it for performance. So if nobody's listening, why create the event object? This matters when events fire frequently. And the static dispatch method is just convenience, because callers just write give XP event.dispatch. They don't need to know about the event bus, the dispatchers, or any of that machinery. So please make sure inside your main plugin class to register the event. Now we can call get event registry and register our class and our handler. In this case, new giveXP handler for the giveXP event and new level up handler for the level up event. So now what we have built is the giveXP event and the level up event. We need to in just a bit create the handlers. So be aware we haven't actually created them yet, but this is how you would register them. So we have the giveXP event, which requests with one handler, and the level up event, which is kind of a notification. And we have static helpers, and it has listener optimization. So events decouple systems. So sources don't need to know handlers. We have like our intent of events, like a request versus a notification. We can chain events. So giveXP handler, for example, dispatches level up event. And we use iEvent for cross-cutting. So we have a global event bus for plugin communication. And we have defined a static dispatch helpers for a clean API, so it hides the event bus complexity. So you also need to ask yourself, okay, who needs to own this logic? One owner means like a request event, many reactors means like a notification event, just for your mindset, kind of. Okay, so let's look at monster kills and how we want to earn XP from combat. So our first XP source. So we have events. Now, how do we actually trigger them? So let's start with the classic. We want to kill monsters. When an entity dies, we check if the killer is a player. And if so, dispatch giveXP event. So how do I detect when something dies? And Hytale has a built-in system for that. The dev systems on dev system. It's a specialized ref change system that triggers when an entity receives a dev component. So the entity takes lethal damage. Hytale adds the dev component to the entity, and the dev component contains a damage class, which contains dev information like who killed it, how, and etc. And the systems extending on dev system get notified, and then the entity is removed from the world, and we will hook into step 4, where by the time we're called, the entity is marked for dev, but is still accessible. So what information do we get from dev component? So dev component provides a method called getDevInfo, and it returns a so-called damage object. So it contains the damage source, for example, who or what caused the dev. And we only care about entity kills, right? Yes. So if the source is damage.entitySource, we can get the kills reference via getRef. Environment devs, for example, use environment source, which has no killer, so we don't have XP for those kind of events. So we have many different source types, and in this case, we want to get the entity source. We could also get like a projectile source, but we could maybe do that in another part. So only entity source and its subclass projectile source have a killer reference. So environment devs don't award XP. So before giving XP, we need to check if the damage object exists, if the source is an entity source, if the killer ref is valid, if the killer is a player, and if the killer has RPG data. It's because each check can fail, and early returns keep the code clean and prevent null pointer exceptions. So let's create our XP gain system inside our systems package. We will start by defining the class where we want to extend devsystems.onDevSystem. So this triggers dev component when it's added. I want to define a static variable called XP per kill, which just defines, hey, how many XP do we get per kill? This is hard-coded right now, but it could also vary by monster type in the future. I want to override the query. In this case, I say I want only entities with dev component, which is triggered by the dev event. We have to override it. I don't know if we just like could return arch type any, or like I don't want to filter, but I just have added this filter, but you may want to double check that if you actually need that. Now we can override the onComponent added method. So there we get the ref, which is the dying entity. We get the dev component, which is the dev info. We get the store to read components, and we get the command buffer, as we have seen it in the last system, to do something with the components. So now let's add all our null checks. First, we want to check if the ref, if the dev component is not null. Then we want to check the dev source, and we want to make sure if it's an instance of damage.entitySource, and we directly cast it into a variable. And you see the exclamation mark, is it called in English, right in front? We want to negate this. So if it's not instance of damage entity source, we want to return it. We want to define an early return. So this is called pattern matching in Java. It checks the type and extracts it into the source variable in one line. Then we want to get the killer ref from the source, source.getRef, so the entity source, and we want to check if it's valid. If it's not valid, the killer might have been disconnected or has been removed, so we need to check if it's valid. Now I can finally get the killer from the component, so which is a player ref. So I pass in the killer reference, which is just the reference to the entity, and I want to get the player reference from the store. And even then I want to check if it's null. So is the killer a player? Or if it's an NPC or another mob, because mobs could kill other mobs. And I don't want to award a mob experience points. So now, finally, when getting the player, I can check, hey, has this player a player RPG component? If not, please return it. And now I can send in a message, hey, you've gained, for example, 50 experience points. And now, only now, I just dispatch the give XP event and nothing else. Because I want to react to a mob's death. This is what we do with the XP gain system. And I just want to dispatch the event, and everything else is getting handled from there. So all checks passed, dispatch the event, and the handler does the rest. So this was also pattern matching in action. So the old way in Java below 16 would be we check if the source is instance of damage entity source, and then we cast it into that. And with Java 16 and upwards, we can just consolidate that into one line. So now we also need to add our system inside our setup method, our XP gain system just above the player join system, but the others shouldn't really matter. And because they're independent. So Hytale manages execution based on system times. So if a monster takes lethal damage, Hytale adds the def component. Then our XP gain system on component added is called. We check the entity source if it's a player and has it the RPG component. If all checks pass, we want to dispatch the giveXP event, and our giveXP handler adds the XP. So, what we've built so far, we have built a player join system, and we have the XP gain system. We have our on-def system, we have def info or damage, we have pattern matching, and we have early returns because we validate before proceeding, and we do event dispatching. So on def system, I know I'm getting a bit repetitive here in the slides, is for def events. We have def component, which has context. We want to filter for relevant kills. We use modern Java language patterns, and we want to dispatch. We want not to process, we want to dispatch. So XP gain system just triggers the events, and this is separation of concerns. XP gain system knows about def. GiveXP handler knows about XP, and neither knows about the other's internals. So now we want to complete the chain and get to level ups. So XP gain system dispatches GiveXP event, but nothing handles it yet, right? And yeah, correct, we need two handlers. GiveXP handler to process XP and level up handler to react to level changes. So how do event handlers work? They implement an interface consumer with an event type. When the event is dispatched, Hytale calls your accept method with the event data. So we have GiveXP event. We want to call GiveXP handler. There, we want to validate the player ref, want to get store from the ref, get the RPG component, call our add experience component, and then check if the level has changed, and if so, dispatch the level up event, which then gets handled by the level up handler, which sends our player a congratulations message. So, as you can see, we call it directly with add experience, but in part 1 we had something like world.execute. So I thought store access needs to be executed on the world thread. And good memory. But look at where GiveXP event is dispatched. It's inside the onComponent added method from the XP gain system. So that is already running on the world thread. So the handler runs on the same thread, and it should. Yes, Hytale's event bus dispatches synchronously. The handler runs immediately on the same thread as the caller. So no thread hub and no world.execute needed. So it always happens on the same thread, and store.get component is safe inside our handler because we are on the world thread. The event bus doesn't queue events for later. It calls handlers immediately, preserving the caller's thread context. So we can get the player ref from the event because this is what we have passed ourselves inside the event class, and we can get the store. So it stores a direct pointer, no lookup is needed, and it's created when the entity enters the world. So the store reference is immutable. So we don't need any kind of universe lookups. It's simpler and faster. So let's create our GiveXP handler. We have our class, which implements a consumer interface, and inside, in the brackets, we give it our GiveXP event as a generic. Now we want to override the accept method, which takes our event as a parameter. And first of all, we want to check if our player ref is valid. If not, just return. So because the player might have been disconnected. Now we want to get the store. Event.get playerref.get store. So, and as I said, it's a direct pointer. We don't need a universe lookup. Now I can get the component from the store. So for this player ref, I want to get the player RPG component. And if it's null, return it. Now I can get the old level when I just call rpg.getLevel before I add the experience, and then I can add leveled up with the rpg add experience method, which returns, hey, has the player leveled up or no? So we need to track the level before adding experience points, because add experience returns true if leveled up. And then I can dispatch the level up event, and I give it the player ref, I give it the old level, and I fetch the new current level from the RPG component. So is the level increased? Dispatch level up event, and other handlers can react. And this is basically everything we need to do for our GiveXP handler. We want to get the player ref, we want to get the store, we want to get a component, and we want to add the call the method from the player RPG component. And this is everything we need. So our Hytale player RPG component add experience returns true if the player leveled up, and we don't need to compare levels manually. Now let's create inside our handlers package the level up handler, which also implements the consumer interface. And we also want to override the accept method, and we also want to check if the player ref is valid. So it's the same validation pattern as before. We want to get the store, and we want to get the player ref from the store and return if the player ref is null. So now we have valid data. And now I just use a switch pattern. So I call the levels gained method, which we have defined previously inside the event, which just was a little helper method. And I have two cases. It's like a little bit overkill with this switch method for just two cases. But in the case I have only leveled up one level, I say, hey, level up, you are now level, and pass in the parameter. And in any other cases where we have multiple level ups, I say, hey, level up plus X levels. So example, hey, you have gained 2 levels. You are now level 3, for example. This is a switch expression which is clean, concise, and it handles single versus multi level up. And then I just go ahead and send a message to the player ref. And this is a very great example of separation of concerns. So we use the switch on levels gained just like, for example, if someone gets 10,000 XP at once, they might jump from level 1 to level 5, and the message, in my case, should just reflect that. So we just send different messages. Now, please make sure to register the handler inside our setup method if you haven't done it already. And this should be it. So we have both handlers registered, and when giveXP handler dispatches level up event, level up handler receives it immediately. So this would be the complete flow of our system. And once it dies, we call the event bus, get XP, get level ups, and send the handler a congratulation message. And all done, and the tick continues. So inside our packages, inside our handlers package, we have created the giveXP handler and the level up handler. We have our consumer interface. We use ref.getStore to get direct store access. We use a synchronous dispatch, so we are on the same thread, and we use event chaining, so giveXP triggers level up in the same tick. Handlers are basically consumers, so we have consumers with an accept method. We use the direct pointer, we use synchronous, and why do I have repetitive stuff on here? That's not good. But for example, the design inside here would be that Hytale's synchronous event bus preserves thread context. If you dispatch from world thread, handlers run on world thread. It's simple and efficient. At last, part 6, debug commands. So the system works, and maybe you have compiled it and tested it, and you should see a message inside your chat when you kill a monster. But how do I test it without killing monsters? And we want just to create some simple debug commands. We will create RPG XP to give yourself XP and RPG stats to check your progress. And it's essential for development. And we will create a spawn method. So we can extend base classes. I have made a full video about the Hytale command API. So we have something called abstract command collection for command groups, an abstract player command for player-only commands, and Hytale handles parsing, validation, and the help text. So I want to create an abstract command collection which handles XP, statistics, and spawn of monsters, so we can just easily test it ourselves. And abstract player command specifically is a convenience class that only allows players to run a command, not a console, and gives you the player's entity ref, store, and world directly. So the advantage is that you don't need to look those up yourself. The execute method receives everything you need, and it already runs on the world thread. No world execute needed. So those are all the parameters we get passed. We are ready to use. So inside your commands package, please create a new class called RPG command, which extends the abstract command collection. Inside the constructor, we define, why did I go back? So we define, now I have jumped. Oh my God, I'm sorry. So inside the constructor, we define the base name for the command collection and the description. And we call the add subcommand, and we call the constructors from our 3 different subcommands. And inside our subcommands, we want to use optional arguments, for example, for XP. And we can use it with a helper method called with optional arg in our constructor. It returns a optional arg type with a generic that we can store as a field. And for validation, we want to use the Hytale's built-in validators, so we can send automatically generated error messages. So for our first command, RPG XP command, we want to extend the abstract player command. Then we want to define a default amount, in this case 50, and an optional argument. And I think I could have also used like default argument for that. I'm not quite sure why I didn't do that. Please watch my command API video for the patterns. Now inside the constructor, we can call the super method, which defines the name of the command in this case, xp. But since we are using it as a command collection, it's like the subcommand. So it would be /rpg space xp. We can define the argument, in this case a name, a description, and the data type. And I add a validator that I say, hey, the amount must be greater than 0. So we have input validation. Now I override the execute method and I get all the ECS context provided, which I need. I take the amount argument and I check if it's null. If so, I want to initialize it as the default amount, but I'm sure you could use default argument for that, not optional argument. Then I want to check if the player has an RPG component. If not, hey, send a message, hey, no RPG data found, and return it. And then I want to send a message, hey, plus x XP, and I want to dispatch the give XP event. And do you see the beauty now? Do you see the beauty of it now? I don't need to have multiple logic inside the XP gain system and the command. I just can dispatch the give XP event, and it's the same event as monster kills. The give XP handler processes it, and it's very, very elegant. So commands use exactly the same events, and this is the power of events. Both trigger the same give XP handler. Level up detection, messages, everything works identically. One code path and multiple entry points. So let's go ahead and create our RPG stats command. So we want to show like the statistics, everything we have saved for this player. And we don't need arguments, we just need a name and a description. We also override the execute method. We check if the player has the player RPG component. And then I want to extract everything we have got from this RPG component from the methods we have defined earlier. So the get level, get total experience, get current level XP, get XP to next level, and the progress, which I parse as an integer and multiply it by 100, so we get like the percentage of it in full numbers. And then I just send a message with like some strings and concatenations and say, hey, this is your level. And if you're max level, maybe put it in brackets behind that. This is your total experience points. But if you are not max level, I want to show you your progress. So how much XP in your current level bracket have you got? And how much XP do you need for your next level up? And what would that progress be in percentage with 0 digits? So only show the progress if it's not max level. We don't want to show no point showing 0 XP to the next at max. So this is just like a sanity check. And this is our RPG stats command. But what about testing monster kills? I need monsters to kill, and that's what RPG spawn is for. We will spawn NPCs around you. It's perfect for testing the XP system without hunting mobs. And we want to define a optional type argument and count argument to say, hey, I want to spawn 5 skeletons, or I want to spawn 10 zombies around me. So those are all the imports. I have some Java docs provided for an example on how to use it. It just helps. Then I create the RPG spawn command with the extension of abstract player command. I define some defaults, like for example, the default type, which would be a skeleton entity. I want the default count and the max count. And now I add optional arguments and I define them inside the constructor. And I add validators. In this case, I want the amount to be between 1 and 50. And I have found a greater than or equal, but I haven't found a less than or equal. So I do max count plus 1. So it needs to be greater or equal 1 or below 51. So 50 would be below 51. So that's just a little edge case here. And then I just go ahead and get the arguments and initialize them with the default value. And I get the transform component from the reference because I want to get the player position, and the transform component holds the position and the rotation from this specific entity. And then I use the so-called NPC plugin class, which just helps me to get a specific NPC for a specific type. If it's not found, I want to say, hey, unknown NPC, non-playable character, which a skeleton would be. It is a non-playable character. So if it's negative, it's unknown. And then I want to get the player position from the transform component. I want to get the world store from the entity store. I want to get a random number from thread local random.current. and I want to count how many NPCs we have spawned. So now I just make a simple for loop and initialize it with the count we have passed, and I define a new vector class which just makes some little small variations to the position. So we get the X, Y, and Z coordinates, and I just want to say, okay, get the Y axis and just add a little bit space to it. And then for the player position on X and Z, I just want to say, hey, just make a slight variation for the position so it gets randomly positioned around the player. And then I want to call spawn NPC from the NPC plugin and pass in the world store, the NPC type, null, just pass null, the span position, and a new vector for that. So it gets randomly positioned inside a 6x6 area and centered on the player and slightly above ground. And it gets a result. And if the result isn't null, we can increment spawned, so we know how many entities we have spawned, because it may return null on failure. So I don't know, we just need to do some defensive kind of programming there. And then I can send a message back to the player and say, hey, you have spawned so and so many different entities. So for example, if I now type in /RPG stats, I get my stats, my total XP, my progress to the next level. I can give myself XP and say level up, hey, you're now level 5. Or I can spawn 10 zombies or 10 skeletons to test my XP gain system. So please make sure in your setup method to get the command registry and register the command, and then you should be good to go. So the collection handles the routing to XP, stats, spawn, and so on. We just need to register the collection, not the individual subcommands. So this is what we have built so far. We have built our command collection and then the 3 separate subcommands. So we use abstract command collection to group related commands under one prefix. We use abstract player command to use player-only commands, and it provides the full ECS context. We use optional logs and validators to use type-safe arguments with built-in validation. And commands reuse events. We use the same givexp event in our XP command as monster kills. And the world fed is guaranteed. We don't need world execute in our commands. And debug commands are very essential. Build them early, use them often, because it's easier than killing 200 monsters, for example. So, okay. A little wrap up. I'm very glad that you have continued until this, and you should have a working plugin by now. So, our complete system is we have our plugin setup in RPG Systems Tutorial, or however you called it, which registers components, systems, events, and commands. We have our data layer with our XP table class and the player RPG component class. We have our systems layer with the player join system and the XP gain system. We have our command layer with our command collection and the subcommands. And then we have our events, givexp event and level up event, which both have their handlers, like givexp handler and level up handler. So this should be the complete file structure you should have been going on inside your project right now. So what have we learned? We have taken a look at data modeling. So we only want to store what we need. If we can derive anything, we should derive it. We have implemented lookup tables for game balance or game features, and we used codecs for persistence. Inside ECS, we know components hold data, system hold logic. We have a RefSystem for the entity lifecycle and the command buffer for save writes. And we have the event architecture. We have some kind of request events, as I call them. We have notification events, and we have a synchronous dispatch that preserves the thread context. So we only wanted to store XP because we want a single source of truth. We wanted a lookup table because we want to balance changes without migrations. We want I-event over ECS event because we have cross-system communication, not directly related to entities. We have the get store to get direct access, and we have event chaining for clean separation. And now, the limits are only your imagination. You can add different kind of gameplay features. You can, for example, add different XP per monster type, or you can add XP multipliers. You can add level up rewards, for example, or you can add some kind of prestige system. We can also add a XP bar overlay, or leaderboards, or a level up particle and sound system. Or we could use database storage for cross-server storage persistence and could use statistics tracking. So you can use those patterns we have implemented in any different kind of systems, like the lookup table or the player initialization for a welcome system or the event chaining, any cause, causes and effect flow, and so on. And we will go further into those systems and other ideas in the next video. So thank you very much for watching. Please drop your questions and feedback in the comments below. It was a little bit of a longer video. I guess the next videos will get a little bit shorter, like around the half-an-hour mark, because it's easier for me to produce, but I just wanted to finish this video and I didn't know that it would get so huge, because the code isn't actually that huge, but the explanation of that is getting very huge. So thank you for watching and see you again in the next video.